Hey everyone, welcome to this first virtual CodeReach session. I hope you guys have been having a great break and really enjoying yourselves and relaxing, but still getting a little bit of work done. So this is kind of how the rest of our CodeReach sessions will go. We have 4 left, and we're just doing this so that you guys can round off the year. We can finish what we started. So the format basically will go that we will be pre-recording an instruction video, and then after we'll be playing it back as a live stream on Thursdays at the regular time. So what this means is that although we won't get the interactivity of changing the lesson, we'll be in the live stream chat, and you'll be able to see the lesson at the same time that everyone else is seeing the lesson. So if you have any questions or comments or concerns, you can just put them in the live stream chat, and then after we will be here as the volunteers and the teachers. We'll be there to help you out. If you have any questions, we'll be able to answer them, or if we forgot something, we can put that in the chat as well. And then after this will just let us keep an interactive environment without having to deal with all of the craziness of live stream and stuff dropping out and the pretty long delay when you are live streaming. This allows everyone to see everything at the exact same time, so we have questions at the exact same time as well. All right, so let's just jump in to week 18, which is file IO. All right, so over the course of the past 2 months, we've been really exploring how to actually make programs, how they work, different libraries. But a program is pretty useless if we can't actually get any input or output, right? If it can't get information and if it can't output information, it's really not anything useful. To remedy this, we've been using console-based input primarily with print and input, and we've also been using Pygame, right? That allows us to do graphical-based output and keyboard and mouse-based input. However, sometimes you don't want to be sitting at a terminal typing stuff in, but you also don't need a fancy graphics user interface. So what comes in here is file IO. File IO lets you feed information to the program and let it write information without you needing to be there necessarily. So let's say I were to create this simple program to calculate a student's average. So let's just run this for example. So we have the student's name. Let's just put SAT and let's put their marks. So 18%, I guess 90, 100, and 98, and 50, and 60. So then after, he has an average of 69.33. Now this is fine for a few people, 5, 10, 20, 50 people, but let's say we wanted to calculate the average for everyone at Massey. Obviously that's not going to work. You're not going to be typing, 6 numbers 1,000, 2,000 times. So what we can do instead is give this program a file and let it read and write information automatically without us needing to do anything. So here's an example of the program that does the exact same thing but with file IO. So what I have here is a text file called marks, and I have the exact same format as the input file, so that we did with the console. So we have the name, and after we have their grades separated by spaces. This is a common way of specifying information. Another one is called CSV. So that stands for comma separated value. So instead of using spaces, you'll use commas. Because like words and sentences can have spaces, right? So sometimes it can get confusing. But let's just open up this example now. So what we can see here is if I just run this, all right, I just get an averages.txt, and I get everyone's average all in one file, right? So for example, come report card time, we just print this off, cut them off, and then after everyone gets their average or whatever. Obviously it's not that simple, but right, you can see how useful this is, especially let's say that if each operation takes like 2 seconds, right? If I'm like resizing a photo or downloading a file, if I'm doing that 2,000 times, 10,000, 100,000 times, I might be waiting for like 2-3 days and just sitting there giving it information when I could just give it a file. So that's really the beauty of file IO. And one thing to note though is that you don't need to only have file-based IO or only console-based IO, right? With Pygame, we had console displaying some debug information and the graphics doing the main thing, right? And even a game, we can combine all three where we have those two, and plus we have the text file or any other file for like save data or player skins or stuff, right? So please don't think of this as an either or, but this is more of a mix. You can do a lot. right? We could have it so that it takes an input file, but then it outputs to the console as well. All right, so the base of all Python file input and output is the file object. The file object allows you to open, read, write, and close files and do basically all the operations you could think of on the file. So to make one, you simply have a variable name and you say equals open and you put the file name followed by the mode. Now there are many modes here, right? We have R, RB, R plus, RB plus, W and A and B. But normally you'll only need to deal with W, R, A along with their plus variants. So like R plus, W plus, stuff like that. So what W is, it stands for write. However, note that if you use W, this will delete any file that was already there. So if I already have a names.txt and then I run Python and create a file object with the mode W, it'll overwrite that old names.txt. However, with append, it'll just add it to the end of the file. This is useful for like a log or something, and then reading is pretty self-explanatory. So an important note is that once you're done reading or writing a file, make sure you run file.close or whatever the variable name .close. Otherwise, your changes, first of all, might be lost if you're writing to the file, or you might be wasting resources and giving that dreaded "this file is currently in use." All right, so now that we know what a file object is, let's look into how we can use it to read and write files. So the first thing we're going to learn about is how to read files. So all we do is we just create a variable and then after use open. Now remember that R is the default mode, so we don't need to put R. So the first thing we can do is just simply read the whole file. So if we go ahead and run this, this will just put this is line 1, this is line 2, this is line 3. Simple as that, same as a notepad, okay? Now the second way we can do that is using .readline. So this reads the file line by line, similar to how you read input. So if we just uncomment this over here, we can see that this reads the lines, it keeps track of where it is. So the first time it does this is line 1, the second time this is line 2. Okay, so this is anywhere in the program, it keeps track of where it is, just like input. Now the third way we can do this is simply by using a loop. So we can use the for in structure, and that prints out the whole the whole file line by line. So this is useful if you want to go through the whole file, but you need to look through everything line by line. Now finally, of course, for every single time, we're using f.close to close the file and release our lock on it. Now one thing to note with f.readline is that it includes the newline character. So what that means is that in the file, for example, when you type in enter, you're actually creating a new line character, right? \n. So when it's reading the line, it reads everything. So that means that when we're doing this print statement right here, we don't need it to add a new line automatically. Remember that print automatically adds a new line. If we get rid of this for both of these, what we can see here is that we'll have 2 spaces instead of just 1. No, I forgot to comment that one out. We'll see we have 2 spaces instead of just 1 because there's already a new line from the file, and then after we have another one from print. Now, if you don't want to use a loop, but you somehow, for some reason, want to read line by line, the way that you can check that you're at the end of the file is by checking for an empty string. If it's just a simple new line like that, where you're just creating new spaces right here, they'll have a new line character. However, at the end of the file, you'll have just a blank string. So I'll have an example over here, just to tell you what I'm talking about. Is if we open this file, we see that we can just run this over here. And as we keep running this, it tells us we're at the end. So you can keep running it over and over and over again. And then after, you still get the same thing, which is a blank string. All right, so that is just a little tidbit in case you're going to ever use it. Honestly, I've never used it though. All right, so the next thing we're going to look at is how to write files. Now, some people might perceive this as somehow harder, but in fact, it's actually easier in Python to write files and to read files. There's only one method you need to know, which is .write. So as you can see here, we're just creating another file object, but this time we're indicating W, which means that we are creating a new file and overwriting anything that's already been created. If we want to just add it to the end of the file, we can use A, but we're just going to use W for now. So as you can see here, write accepts a string and a string only. So that means that if you want to print out a number, such as the age of 18, you need to first convert it to a string. Now, using .close with a file is, when you're writing a file, is actually extremely important because sometimes Python tells you it's been written to a file, but in fact it's only been cached in memory. Until you write .close, there is no guarantee that your file has actually been written to disk. So if we go ahead and just run this program, we'll see that we get an out.txt, but what you'll see here is that there is actually no newline character. This is because write, unlike print, does not insert a newline character at the end. So if we do want that new line, all we need to do is add a /n, and then we'll get what we want, probably, which is 18 on the second line. So you'll see here that the contents of our old file was completely erased, and we have a new file over here. Up until this point, we have been closing our files manually with file.close, but this poses a problem for us should our program crash. If it does, our close code won't run, and our file will be left open, and this leads to the incredibly annoying dialogue that you've probably all seen before. I'll just demonstrate what I mean. So we just have this, oh, it crashed, okay, and now let's just try, deleting info. Right, you get this stupid error. And this just prevents other programs from, playing with a file while a program is using a file, right? Imagine that you're halfway through a file and suddenly it's been deleted or something. Obviously, this is something that Windows does to protect you, but it can become really annoying when your program crashes. So to counteract this, we can use something called the with structure. So you guys have been familiar with try, catches, and finallys. With is basically a try and a finally mixed together. So as we can see here, we're simply kind of switching the order. Instead of saying f equals open out.txt, we're saying with open out.txt as f. So now we're still using f as the file object, but in this case, once we're done with the with, it'll automatically be discarded. We don't need to use f.close. So for example, now we can just run this, open this crashy again actually. And if we were to use with, so let's just go ahead and comment all of this out and say with open info.txt, and then let's just crash it. And what you'll see here is it'll automatically be cleaned up. Now the other one's already still going to be locked, so let's just put info A instead. So we can see, oh, whoops, I forgot the colon, but we can see here that, oh, let's go ahead and create it too. All right, so let's create this, and we're just gonna read from it. It crashed, but this time we can try just deleting it, and it still goes away. So we can see here, completely eliminated it, and you just don't need to write that extra piece of code. So this technically saves you one line. Now the with keyword is a lot more useful than just using files. If you ever go deeper into Python, you'll see that there are a whole bunch of other functions that benefit from using with, so that they're automatically closed and discarded. That is the end of this lesson for this week. I hope you guys were able to understand what we're doing with input and output files and how they really work. Um, as always, if you have any questions, feel free to either put it in the chat or message me directly on Edmodo, and I'll be happy to help you out. Now for this week, what I'd like you guys to do is to reopen your game project that you did a few weeks back and finished a few weeks back, and try to add saving with a file. This is a pretty common thing to do, and I want you to guys just really experiment with the best way you can represent your player's state and the game state with a file, and the best way for you to actually retrieve it. All right, so we'll discuss that next week, and we'll continue with some more advanced topics in Python as we finish the year. All right, so hope you guys learned something, and I'll see you virtually next week.